We're back with another amazing talk, and again, I thank everybody for the generosity for donation. Donation are still open, so please give back. And we have Maisha, Lohani, and Sajeeb. They're going to talk about Wi-Fi security. So let me add them on the stream. Maisha, Sajeeb, you are on.
Hey,
Can you
thank
hear
you.
me right?
Hi.
Yeah.
Hi, how you doing? All right. If you want to share your screen, this stage is yours.
Perfect. Thank you. Cool. Just to get things started, welcome to Unlimited Wi-Fi, bypassing captive portals and proxies with a twist. Do you even remember how we started with this talk?
Now thinking about it, no, not really.
I think it was actually something to do with the fact that we were stuck in an airport, delayed as always, and we were wondering what to do. We ran out of Wi-Fi because we've been binge watching things on YouTube, and the airlines actually wanted us to, either pay for the Wi-Fi or give our personal information. And I think it was actually then that we started sitting down and trying to find different ways of bypassing these captive portals and proxies with our own little twist. Well, hey, my name's Sajeeb Lohani. I'm a senior pen tester at Privasec Red in Melbourne, Australia, and the land down under. I rank within the top 50 in Bug Crowd, and I'm a co-author of Interlace and Dr. Watson, and I also lecture in Melbourne University.
Hi, I'm Maisha. I'm currently a student in Swimmer University. I'm a committee member for the AWSN Cadets Melbourne and help out with AWSN events as well. I like to volunteer. I've volunteered for organizations like Kids Security Day, where I actually spoke, besides Melbourne and AWSN.
Awesome. So a quick rundown of the things that we're going to be going through today include the different types of attacks, like, different attack methods and vectors that we can use to our advantage to bypass all of these protections in place. We're also going to be talking about the benefits of each and every one of these methods, and we're going to try our own little way as cheap and quickly as possible to mitigate each of these vectors. Back to you.
Alrighty, so when people look at bypassing captive portals and proxies, they usually look at infrastructure attacks. But we're going to start with application attacks, as they're most commonly forgotten. They can help with things like authentication bypasses within the application. So let's get started. I'm going to start with SQL injection. And the first thing I'm going to do is kind of give a picture of what a normal SQL query would look like. So imagine you're in a warehouse and there's a robot. You tell that robot to please go to this row, this shelf, fetch this item, then you pay for it and you get to walk out of the warehouse with that item. Now, in order to make that into an SQL injection attack, we need to be more specific and we need to manipulate it a little bit more. So what we'd say for that is to the robot, please go to row 2, shelf 3, fetch me a laptop, then go back to your window, pass me the laptop, and forget that any of this ever happened. Now, you have the laptop in hand, you get to walk out of the warehouse without having to pay for it, everything's jolly good. So now for the benefits of an SQL injection is authentication bypass, which is great. You can sell credentials, which will make you money. It's dodgy, but it'll make you money. Selling Wi-Fi, and best of all, free Wi-Fi, because we never want to pay for Wi-Fi again. Now for the remediations of SQL injection. So the first one would probably be not to load user input directly into the SQL query, but instead using parameterized queries. This is because string concatenation actually leaves you vulnerable to SQL injection. The next one would be ORM frameworks. They provide functions for us to interact with different objects in a simple manner. They provide us with a certain level of security to each of the functions too. We thoroughly recommend using them in their proper intended way. Unfortunately, they're not stupid proof. My favorite ORM framework would probably be Cake PHP. Now moving on to infrastructure attacks. So the first one we're going to look at is media access control, or MAC spoofing. So for that, I'm first actually going to explain what NIC, or network interface card, is. So every adapter that connects to a network and can send and receive packets is a NIC. The reason for explaining that is MAC is a unique identifier for NIC. And spoofing is basically like a spy disguise when you're trying to disguise yourself to look like something or someone else. If you put those two concepts together, you get MAC spoofing, which basically means you're disguising yourself to look like a different MAC address. Now for the attack of MAC spoofing. So we would use AeroDump for wireless networks and Wireshark to sniff the network and identify MAC addresses that are in use. We would then use MAC changer with this command, macchanger-m, the MAC address and the adapter name. We would then continuously keep sending ARP packets. The ARP packets are saying that we are that MAC address, causing the CAN table within the switch to overflow. The switch then sends you the responses. We then move on to using a curl command to specify the adapter and request a URL. The command for that is curl --interface, the adapter name, and the URL that you actually want to request. Some of the benefits for MAC spoofing require you to abuse the whitelist, and that way you can get authenticated access. And also, as seen in some research done by CJ, whitelisted MAC addresses may provide higher bandwidth, which can be quite beneficial if you want to maybe download something or if you want to play some games. For the remediation of MAC spoofing, you would want to have a limited number of MAC addresses per physical port. That would help. And ensuring MAC addresses come from the expected physical port and not just some random one. Now we're going to move on to IP stealing. So the way you would use IP stealing is you would wait and watch a whitelisted IP and use it when it's not active, or you could statically assign IP address and send lots of traffic gaining priority on that network. The remediation for IP stealing would be to restrict the IP to a physical port, and this would generally be done using a layer 3 switch. Now for credential stealing, the way we would use credential stealing is, again, we would use AeroDump for wireless networks and Wireshark to network sniff and monitor the network for plain text credentials. These plain text credentials may give you access to the admin panel of the router or the captive portal, which allows you to reconfigure it. Now, some of the benefits for IP stealing and cred stealing is, again, authentication bypass, selling credentials, dodgy but makes you money, selling Wi-Fi, and best of all, free Wi-Fi, because we never want to pay for Wi-Fi again. And the remediation for credential stealing would, number one, be proper implementation of TLS, using encrypted protocols only, and lastly, using a fully switched network so that people can't actually sniff each other within that network. Well, that's it from me. Tag, you're it.
Awesome, thank you. So I'm going to be talking about secure shell tunneling, or SSH tunneling. So for people who don't know what SSH is, it's basically a nice little protocol wrapped around a secure little protocol. And it's a set of rules that allow you to go and put yourself into another computer, a remote computer, and it allows you to run operating system commands within that computer. It works really well, and since it's encrypted, it's a preferred method of communication for normal people. It's used a fair bit in places like development environments and things like that. So how you would generally use it is something like SSH-P, say 1337 or whatever port you want to connect to, -I, and then the certificate, because, well, we're not ancient, we're actually using certificate authentication. This is security. And then the username @ and then whatever IP address you want to use. Now, the interesting thing is we can use this to tunnel our traffic in through the SSH tunnel really simply. Since it's encrypted, the admins who are actually monitoring the air-gapped network that we're currently in won't be able to see the exact traffic that you're sending. So you're free to do whatever you want as long as SSH is enabled. We can use -D to do port forwarding, and then pretty much configure the browser to use a SOCKS proxy, and then pipe all of its traffic through that specific port, nice and easy. Now, some of the benefits of doing this is it's really simple to set up. All you need is something like AWS or DigitalOcean, who will actually set up the SSH configuration for you automatically. It's encrypted communication, so it's super simple, and it's actually reasonably secure. It's fast, reliable, because it's based on TCP. And finally, it's cheap. If you do it on a small server, it'll cost you like $5 a month. So, I mean, that's great. But now, how can we actually remediate this? We actually sat down for a fair bit of time trying to find a good remediation for this thing. It turns out my initial thought was, why don't we just ban port 22? But yeah, as simply as we said before, we can just specify a different port, put SSH on that port, and then go and communicate. So the answer that we came up with was using something like deep packet inspection to go through and monitor the traffic and try to identify SSH traffic. We go through all of the network logs, find anything SSH, and then disable it right away. That way, it no longer goes through. But how do we bypass things if we don't have SSH? So we're going to move on to our next method and try to find different bypasses. So for next, we have DNS tunneling, or domain name service tunneling. So domain name service is basically something like the phone book for the internet. So what happens in a traditional phone book? Basically, you have a name and you have a phone number. Nice and simple, they correlate. In DNS, you have a domain name and the IP address it correlates to in the most simplistic manner. Now, something you need to note for DNS is it's unencrypted communication, so anyone can monitor what you're doing. It's not reliable because it uses unordered UDP packets, so it's not the best. But the main thing that we're stressing here is even though it's not perfectly reliable, it definitely is unrestricted in a majority of networks. Admins forget to block DNS purely because they assume their users really need it to go to things like google.com or youtube.com or things like that. So usually DNS is quite open to everyone and you can do almost anything you want with it. So we came up with a simple demo of how DNS tunneling can work. Here, we're actually going to go through and try to simply curl google.com. And you'll see that it doesn't work, quite simply. Next, we're going to set up, we have another box outside, which is on AWS. And we basically go and try to do everything from there. So here we can see we're waiting, it times out, nothing great. So we'll head over to our AWS box, and we have sudo iodine d and then 10.0.0.1, our private IP address, and test.com, the domain name inside our authoritative domain name server, DNS server. So iodine is basically the software we're using, and we need sudo because we actually set up a DNS listener on the box. Here we enter in our own password, nice and easy, and it starts listening for anything related to test.com, so it can do its interactions. Now we're going to head over to the box inside the air-gapped network. Note this is a simulation, so it's not perfect. We have iodine client, and then we give it the public IP address and the domain name that we're actually connecting to. So here we simply just go in, pop in our password, and we now look at the different fragment sizes. So here what we're actually doing is trying to find the optimal size of a packet so that we can get across the most amount of data to the server in the most efficient way, yet the most reliable way. And here we can see that we've actually got the perfect size, which is 1174. Now we're going to run ifconfig to see whether the adapter is properly being set up. Here you can see DNS0 with the private IP address 10.0.0.2. So now what can we do with that? Maybe we're going to actually try to go and SSH into the box, the previous box. So we'll go SSH-I with our PEM, and then go into 10.0.0.1, and perfectly we've logged into our AWS box. Now let's try doing curl google.com. As we couldn't do it previously, now we can. In other words, we've now basically gone through, used DNS to SSH, and we've bypassed everything nice and easy. So some of the benefits of actually doing this are things like the fact that a VPS is really cheap, yet again, $5 a month. It's simple to set up because all you need is SSH and iodine. It's encrypted communications because even though you're using DNS, you're still doing an SSH terminal through that. It's usually unrestricted, so it's great because people, aren't looking out for it, usually. However, one major flaw in it is it's not particularly reliable. It's quite slow, but oh well, it's something at least. You can download your payloads using it or exfiltrate your data. So some remediations that we came up with were you could actually tell anyone on your network that you could actually have policies and things set up for all SOBs or any computers actually touching your network, stating that only specific DNS servers are allowed to go are allowed to be used. So maybe something like 8.8.8.8 Google's or 1.1.1.1 Cloudflare's are trusted, and then they're allowed to go and use them. Otherwise, nothing else is actually allowed. So that's one great way of doing it. However, it's quite restrictive. The other way that we came up with wasn't as good, in my opinion, but it's still a viable solution, which is rate limiting the DNS queries. So I can't see the reason why anyone would do probably like 20 or 30 DNS calls per second. If they're doing that, something dodgy is probably going on. So instead, you can actually just rate limit the amount, saying, hey, I can foresee someone doing 10 queries, but not 15. So we'll cut it off at 12. And after that, it slows down, saying, okay, now it's going to go a little bit slower, so you can't exfiltrate as much data using the DNS tunneling. So that's one way, but what happens if DNS is a little bit more restricted in this case? We'll look into maybe something like subdomain service tunneling. So subdomain service tunneling is a nice little fancy way of saying using whitelisted domains that are overly scoped. So imagine having something like Google Ads or ads being served from an S3 bucket. Now, this is actually something we learned from a DEF CON talk. So hats off to them for finding this. It's a really cool thing. But basically, imagine someone serving all of their ads from an S3 bucket. They've now whitelisted all.amazonaws.com. So a fun lesson learned fact is EC2 instances, every single EC2 instance has a public domain name. It's something like EC2 and then hyphenated IP address.amazonaws.com or something like that. I'm not 100% sure. But yeah, basically that also falls under the same TLD as S3 buckets. So if you've gone and whitelisted all out of amazonaws.com, now we can just spin up a simple EC2 instance and SSH in because it's whitelisted and we no longer care. So that's a great way of bypassing things, and it does actually help a lot for some air gap networks where things are a little bit more challenging than normal. So a certain remediation that we came up with was, hey, why don't you just stop allowing wildcards? It could be something as simple as either saying, hey, you can only use this specific S3 bucket, that would remediate a majority of the issue, or constricting it, saying, hey, you can only use S3 buckets from within this region, like AP Southwest, Southeast 1 or something like that. The other thing you can do is using monitoring tools for networks and trying to build rules around it so you can either catch on to different things that are currently being exploited or, just anything around that entire section. I am aware that these aren't perfectly foolproof, but hey, they're good enough to at least get you by. So what happens if you actually don't have a subdomain that you can actually tunnel through? So we came up with a fun new way of doing things, and we call it Outlook tunneling. So this actually came from a fun little experiment that we had when we were stuck inside a SOC, and we're trying to figure out ways of downloading our payloads. But the SOC obviously trying to lock everything down and making sure we can't exfiltrate information said, no, you can't go and download your payloads. No, you can't send information outside. They even had DNS locked down quite a lot. But we found while using our normal systems that Office 365 was still active. We were still able to send and receive emails from my colleagues. So what did we do instead? We pretty much sat down at home and wrote up a quick script. The script would go and set up an IMAP listener and SMTP. So it would receive emails, reply, and communicate to everything in one simple single hit. So here's a bit of a flow of how it actually works. We'd send an email to the Office 365 servers. It would send via SMTP to the ruffle.live for our own mail server. Then we'd receive the email into our web proxy, which would then go and perform the entire request, say hypothetically Disney.com. It'll send the email back to, or send the actual zip back to ruffle.live, send it using SMTP back to Office 365, and then back to us, where we're able to do whatever we want, however we want. And yeah, it's nice, simple, and easy. Now, I understand that that may be slightly confusing, so we do have a demo for you. Now, the demo is quite simple. We start off with Outlook.com. We have an Outlook client working. Everything's fine. Now we're going to go over and check out the Linux system. Here we have the code. So we start off with processing the email, where we actually walk through every single attachment inside the email, going through trying to find text plain so that we can find the actual text inside it. Then we parse the actual URL outside of it and then pipe it into a system command. Now, I'm very well aware that this is vulnerable to command injection, but well, this is just a hack put together for fun, so deal with it. And yeah, basically we send out the email. So this is the email sending script. We basically use SMTP encrypted to go and do everything and pretty much just attach a nice little zip file and then send it back to ourselves. So it's a very, very simple script, nothing very complicated, and it works perfectly. Now we're going to look at the cloning script too, so that I can give you an idea of how we actually did the full cloning. So we quickly just made a simple directory for downloads. We used httrack, which is a very old piece of software, to go and actually make a full working copy of the website. And then we zip it up and then send it back to ourselves and remove the unwanted files. httrack actually proved very, very useful for this because other tools weren't actually performing the way I was hoping for them to perform. So let's kick off the mailing the mail listener to see how things actually work. Here we can see it's listening, all authentication's gone through, everything's perfect. Now we're going to quickly open up a new email. We'll email bypass@roffle.live, send that it's a test email, so, well, it is, so big deal. And we'll pop in my website, odd.zone, and hit send. Now we're going to move over to the Linux box again, and we're going to watch until it finds the email. So it's found it, it's done the clone, it's zipped it up again, and it's sent it back to me within the matter of seconds. Here you can see the emails back to us really simply, really easily. And now we're opening up the download zip, saving it eventually on our desktop. As you can see, I take time to navigate around a Windows system. I mean, Linux is the better way of doing things, but oh well. Then we pretty much use a graphical interface to go and unzip the downloads folder, go into the downloads folder, and attempt to find the website. And here we have a fully functional version of the OddZone website. Here you can see the JavaScript is still intact, the CSS is perfectly intact, and we can do pretty much anything and everything we would be able to do if we had the full website active, which is really nice. So some of the benefits of this is the fact that it's custom really does help a lot. It basically means that when someone's looking for certain ways to detect each of these things, we no longer have to care because they're less likely to find them. It's really cool and was really fun to make. It's cheap because you need a $5 VPS and a domain name, so you could do it in under $10. And it's pretty simple to set up once you have Python down pat. So remediations, we found that it's actually pretty hard to remediate this purely because it's a clusterfuck of craziness. And you have to actually get around different rules, so it's quite custom per different way of doing things. Rate limiting will help, but it won't be the only solution. But one of the major things that we wanted to bring into this talk is the fact that the opportunities for bypassing things are endless. You can have things like, just like we used Skype, just like we use Outlook, we can use Skype, Link, or whatever they're calling it now. That could also be a whitelisted tool. Basically, anything with an API that allows you to access and read things. So hypothetically, it could be something like Jira. We've done it on Jira before, where you can listen and find new Jira tickets as they're coming in using the API, and then parse certain information out, and then reply with a file attachment, and that's it. That has now become your whitelisted API proxy. Really simple, and you can use Jira for it. You could literally do it with anything where you have programmatic access, and making it simple and very, very useful. Just to give you a quick rundown of everything we've gone through today, we've talked about different attack methods, different vectors for breaking through, different types of security, and doing pretty much whatever we want with the system. So we can exfiltrate information. We can also, download anything we want from the internet, and making our lives a lot easier, especially as pen testers. Benefits are pretty much endless. If you're unrestricted, you can do it.
Thank you very much, Shahid. It was brilliant presentation, Maisha, as well. I love the brief introduction and the small story about the airport security. It makes Let's talk a little bit lighter. I love the storytelling. And on the storytelling subject, can you tell any funny story? And then we dive in maybe on a couple of points from the talk. But can you tell any funny story about being a pen tester that you came across? So anything that you can share, of course. Any anecdotes or any nice story that you can share.
Yeah. We've had some very interesting times. I managed to accidentally take down an entire organization in the span of 17 seconds. So I learned local attacks are quite critical. Things do change, but in that same way, I also learned that when you're sitting inside a SOC where everything's most secure or supposed to be, it's not always. So you can also exfiltrate information and do almost anything you want pretty quickly. So yeah, it's been a very fun experience.
But as a pen tester, do you feel the pain for the SOC analyst during a pen test at being on tippy toes, or you just go full on and saying, I'm here to actually wreak havoc?
It's a bit of both. Sometimes it's our job to wreak havoc and not care. But in other times, it's, yeah, we have to take it quiet, carefully, and make sure that we're, not detected. Sometimes they know we're there, but we're supposed to not be able to be detected. So at times we do have to be quite quiet, which it makes the job a little bit less fun, but also does make it quite fun when you actually get fruit out of it without anyone finding out.
No, I love the fact that you've gone through from network all the way up. I haven't seen a lot of exploits going through the network or exploiting the DNS. I know that a lot of exploitation are using it, but not a lot of exploit in DEF CON have shown that depth of breadth all the way to the code. I appreciate the fact also you've gone through the code. So thank you very much for the talk. Maisha, do you want to share something before we close the talk? Any advice for who's starting in pen test, maybe from the both of you, and then we can close?
Well, I'm kind of starting out in pen testing right now as well because I'm currently in university. So mainly I get tips from my brother every now and again, which is great. But yeah, just diving head first helps a lot. It's a really vast thing. You can learn so much, and just finding something because cybersecurity is a very broad term. There's so much going on in it. You can do forensics, you can do pen testing, and so much more. So just finding one of those that you're really passionate about and then running with it.
Fantastic. Thank you very much, guys. I really appreciate the talk.
Yeah, thanks
for having us.
Thank you.
Thank you.